Hello, welcome to another video of this SVA Design YouTube channel. My name is Veldboom, and in this video I would want to take you guys through a little bit of the process of the aerodynamics that I'm going through with the Bizzarini project car. So with that being said, also have a further announcement before I go into the SolidWorks. I also launched the website for SVAdesign.com, and it's spelled SVADesign instead of with the E in there. So if that makes sense, I'll put a link in the description, and I'll also just put it on the screen right now. So that is also live right now. I will do a separate video just to kind of run you guys through the website and to get just to give you guys the rundown of all of the things that I'm working on with the website, the content that will be on there, and all of the projects that I'm working on. But this video was more for the aerodynamics of the vehicle and just in general more Bizzarini project related. So that has been enough for me talking about it. Let's get into the SolidWorks, and I will show you guys the aerodynamics, but also I will also show you guys how to set up the wind tunnel in SolidWorks to do this for your own project, and a couple of the problems that you may run into yourself. So with that being said, let's hop into the SolidWorks. So yeah, I just had to check on something downstairs. I don't know how many of you guys are familiar with like flow simulations and things of that nature in SolidWorks, but it is sometimes a little bit hard to set it up, and you don't really always see where to start with it, things of that nature. So you can literally feel it getting hotter as I'm walking up the stairs. But the first and foremost thing that I always do is to set up the wizard. And it's also basically, for me, the only way that I know how to do it. So yeah, I'm gonna show you right now how to do that. I'm in my SolidWorks right now, and there are a couple of add-ins that you can see right here, and you also have a tab for SolidWorks add-ins. So this is the one that we're going to use today, flow simulations, and hopefully you have it installed in your SolidWorks. And if not, you can if it is in the project that you have, I don't know how to say it, but if it is in the concept package that you receive when you download your SolidWorks, it should be in there in the installation form. So press it if it is there, and then a new tab will open. So as you can see right here, you can see SolidWorks flow simulations, and sometimes this looks different for different people, and I don't really know how to get it to look different, but I basically don't use what is here at all. But sometimes you can kind of make the wind tunnel simulations up with this type of setup. But what I always use is I go to the search bar right here, and you have different tabs for comment, files and models, my SolidWorks, things of that nature. But I also do comments, and I just look for wizard. And the wizard, if you just type enter, a window will open, which is the setup wizard for the wind tunnel simulations, things of that nature. So the first thing that will open is this project, and you can have like different configurations, and with these different configurations means that you can set the car up in different type of scenarios. So if I would like a high downforce setup with a wing and things like that, I don't really know how to do that yet. I will look into it in the future, but then you can have like different setups for the cars and things of that nature. So right now it is just the current setup, default, as simple as it can be. You can name this project, add comments, but you don't really need to, it's not really necessary. So that is the first step. So then you can click next to go to the next step, and then you will open in this window. So this window is kind of set up to create the units and the measurements that you would like to use. So right now I don't really care about mass, I don't really care about pressure. The only thing that I care about is the speed of the air that is moving, and I would like to do it in kilometers an hour. Used to the metric system from Western Europe. So that is the first thing. And then it will ask you if it is an internal or external analysis that you would like to run on the simulation that you're using. And internal means if you have like flows in the engine or exhaust pipes, things of that nature, then it will be internal. And external is for things like this, when the flow is actually going over through something instead of running through pipes and things of that nature. So that is the external. The next thing is that you can set up these physical features, and that is if there is like heat coming off of something, radiation, time dependence, gravity. You could also put gravity in there. I don't really know how much of an effect it will have, but we'll see. I will put it in there just to see what it will do. And the rotation is, I also really don't know things of this nature, but I will have to look up a little bit more for myself as well to kind of see what these things will do, because I also have to learn how to add rotation to the wheels, things of that nature. So I'm not really a great expert in it, but I know how to manage myself with this project and in this way. So then you can go to the next step, and now comes the important part. With the gases, you can select different type of gases that you would like, but this is just the air that we're breathing, so you just double tap that and we'll select the air as the fluid that will run over the car. So the next step, I don't really know what this is at all, but it's just yeah, I don't know, one of these pages that you can just skip. And then here, this is one of the most important parts, and this is the kind of the tab that will tell you in what direction the air is running in and at what velocity. So right now you can see here that this chevron is pointing to the X direction, goes to the left on my screen. So I want the air to go to the right. So in the X direction, I have to put minus 250 kilometers an hour, because it has to go in a negative direction to the chevron. So it has to go in this direction. So then I have the 250 kilometers an hour. 250 kilometers an hour is a little bit of an industry standard at which a lot of people try to use for the aerodynamic test. That is allowed always the test standard of just downforce. If you hear quotes about kilos of being generated, usually it is at 250 kilometers an hour. So that is what I will use as well. And then this gray box will open on the car, and you will also see this little box right here, and I will tell you about all of those things. But maybe it's just good to do it right now. This, as you can see, the window that opens has to do with this box you can see right here. So this is the recognizing fluid volume. And what this does is it checks if all of the lines of the separate body components, if everything lines up properly to the point you don't really get zero thickness geometries. And if you know about SolidWorks, then you know that zero thickness geometries are a real pain in the ass, because if these lines line up in a way that is not good for SolidWorks to kind of calculate the distance between them, it doesn't really know if it is a solid, if it is a surface, if it is, I don't know how to put it, but it can calculate whether air would flow through it or air would flow over it or things of that nature. So it will then just tell you that the complete part is not watertight, or the complete part is not I don't know how to put it. It's just, it won't be able to calculate the aerodynamics of the car because these parts aren't the way they should be. And luckily for me, I already did this, so this shouldn't be a problem right now. All of these parts line up good to the point that they don't interfere with one another. So, but this will take some time. So I will probably just put everything on pause and just let the system run through it. Or maybe I could just talk a little bit about the things that, I'll do that when this is finished. So see you guys in a second. Now the calculation is done, and I can kind of start continuing on with the process of getting all of the things ready where I need it to be. So you can see now that this great big box appeared in the file. And the reason why it is this large is because I also have a floor in this assembly. So now you can see that there's also a floor. And this, I feel like SolidWorks doesn't really have a very accurate model of modeling the way that the air would flow between like the floor surface and things of that nature. So I don't really know how to set it up properly, but I'm getting results that this car is actually producing a little bit of lift, like 70 kilos of lift. And in some situations it is producing something like 200 newtons, yeah, like 20 kilos of downforce. So it fluctuates a little bit. So I'm not very confident in the results, but the most important thing for me is that I can actually see like the visual airflow around the car. So the first thing that I also changed is the computational domain, and this basically means the area where SolidWorks will calculate the airflow in. And the smaller you make it, the shorter it will take to calculate the airflow. So I always just make it as small as possible around the floor. And then also it doesn't really need to be this high. If it is a little bit like this, yeah, a little bit higher, everything around it doesn't really get affected like that. And then you can also do it from the top view to make sure that it's also not too wide. So something like that will be good. So now this is basically the box where SolidWorks will calculate all of the airflow in, and this is also all that you need. So the next thing that you could do is you could set up also the floor, and the way to do this is with boundary conditions, and you can then select the floor, and you can select the floor to even move. So if the airflow is moving 250 kilometers an hour in this direction, then you can make the ground move 250 kilometers in this direction, things of that nature. The way to do that is you go to boundary conditions, you select this icon here to select the wall. You can do a real wall or ideal wall. If you select real wall, you can real wall. I have like pronunciation issues with else at the end of the words. You can then select wall motion, and then you can select 250 kilometers an hour but you also have to select this wall, of course. And then you can select in the y direction, I believe this is in. Yeah, so for me in this case it would be in the y direction, so you can see the chevron and the arrow pointing in that direction. And you can select like the 250 kilometers an hour that the air will be moving as, and then you can start calculating it in that way to also get that added to the wind tunnel effect. But for me right now, just to run the test, I'm going to delete it. I'm not going to use any boundary conditions at all. Just try different stuff, because I feel like it doesn't really work and it doesn't really benefit me, whatever. So the next thing I'm gonna do is insert surface goals. And for these surface goals, it's pretty important. You select basically the parameters, so the force that is calculated in the y direction. So you can see that the y is the vertical plane right here, and that will basically measure the downforce. And then you can also see the force in the x direction, so that will calculate the drag. And then you have to make a selection for which body components you want this calculation to be done for. And for me, I'm gonna just select all of the body panels. So that would be the hood, that would be the front fender, the door. Maybe it is easier if I just select it this way. Yeah, so now you can see that all of these body panels are selected, and also the hood and it's added, but also the carbon fiber monocell, and the side windows, the rear wing, and I have to also do the wheels, and those are in these suspension right here, and also on the front wheels. So now yeah, with a couple of clicks, then all of these will be selected, and then you can see that everything is in blue, the forces are selected, and then you can select that everything is good. So now when you have done that, it will be basically ready to go. And then you can also alter one last thing, and that is the mesh. So you can change the mesh. The mesh is basically the accuracy, so how accurate you want everything to be calculated. So there's a scale from 1 to 7, and I usually put it at something in the middle, around 4. So 7 is very accurate, but it will take a long time to calculate everything. 1 is very basic, it will be pretty quickly, but you don't really get the best results. So I usually put it in the middle. If you have a good computer that could run these things through, put it at 7. You will get the most accurate results. And then there's also this slider right here, and this is also basically the same thing, but just to refine a little bit more to to get just the best results possible. But you can leave this at 1, will be fine. And then I'll just use the select tool, and now you're basically ready to go. So what you do is you right click the project, you select run, and it will start calculating. So now it is 3:15. I will update you guys again on how long it took for me to calculate everything, and you guys have a general idea of how long it will take to calculate. So I'll see you guys back in a second. So yeah, now I have been able to just to start the flow simulation, just kind of running you guys through all of the things that are happening with the car aerodynamically, things of that nature. First and foremost is you can see that everything is basically in blue, which indicates that it is a very low air pressure zone, and probably it is started off that way, but I don't really know what it is supposed to mean, to be honest with you. But I'm right now just checking out the flow simulation, because I can also show you guys some of the goals that I set for it, and also the plots, things of that nature. So goal plots right here, you can then insert and then you can just show all goals and then show, and you will basically get a table of things that are coming up. So here you can see force in the X direction, so that is basically the force that is going in that way. So you can see that it is at minus 200 sorry, my goddamn, I can't read it all. You can see that it's minus 2650 newtons of force. That is basically the force dragging it back in that direction, and I have to equate it to the frontal area, and I will be able to provide you with a coefficient of drag based on that number, and then you will be able to see if the car is very efficient and things of that nature. But I will have to do the calculations, and I will be able to do that. And in the Y direction, you can see that it is at a positive 2487 newtons. So that would mean that the car is being dragged upward instead of being pressed into the ground, with a force of 2487 newtons. So with like maybe 260, 270 kilos of force being pulled up. And also, by the way, the time right now is almost 4 o'clock, and so it almost took like 40 minutes for me to do these calculations. So that is also another thing that you should know. Well, to be honest with you, I don't really know where the number comes from that it is creating lift at this rate, because as you can see, the air kind of falling off the car is being directed upward, and usually when the air is directed upward, the car is being pushed down. So maybe if I would add a floor, it would kind of get a different result, but that is maybe also a good thing to showcase in the video, what the difference would be between having a floor in there and having not a floor in there. So we'll then update the boundary conditions and do the same test all over again. So yeah, that was the first part of the test, and I was also able to show you guys. But the next thing that I wanted to show was to also how to get these flow trajectories, things of that nature. So here are flow trajectories, as I said, and you can just put insert. You select the piece of the car that you want to focus on and where you want to see the airflow. So for now, let's select the diffuser plane, and then you can also select that you want to see the airflow that is going over these surfaces, and with just the Venturi tunnels, things of that nature, right? So with these selected, you can then select, I usually use arrows, and I usually put it at 0.02, and that is just the scale of how large you want these arrows to be. And then you can select OK, the green check, and it will then showcase the trajectory of the air flowing over this diffuser. Yeah, and you can also basically select the diffuser before you start the calculations to see how much downforce individually is being produced by either the splitter, the diffuser, things of that nature. Right? That is basically what you can do with it. So here you can see how the diffuser is affecting the airflow, and it is kind of really dragging that air up, but also that is creating some distortions and also some turbulent airflow. So maybe it would be good for me to add another rake here in this direction to kind of cut off the airflow that is trying to go to the center of the car and to redirect it more straight. Or maybe I should bend these to go more into the center to kind of allow the air how it wants to flow and not really obstruct it more than I'm doing right now. But you can kind of see where the airflow is going. So the diffuser is really just trying to suck the air towards the center of the car, but as well as it's dragging it upward, and it is doing its job. And you can also see that the air is a little bit here in the not in the middle, but more to the left here, is trying to really be sucked up against the body panel here on the back of the car. And also with the separation between the diffuser here, this layer, and before the body panel starts, that is also really meant to get minimum flows to really get the flow to separate from the body panel, to not to get it stuck to the rear of the car. So that is basically what you can see with this part right here. And what else should I demonstrate? Let's also do the flow simulation for the front wing, and then we can also see what how that is directing the air. So you can just select all the body panels you want to use in here, and then let's also select a couple of the end plate components, and you can basically see like the purpose of this whole thing. So now we can see the airflow that is kind of running through the side of the vehicle and also with the front wing. So you can see that there's just really a very strong diversion of the air right here, created by not only the tire but also this panel right here that's kind of directing the air more to the side of the vehicle. And it was meant for that because you kind of want to create a curtain that is separating the airflow along the side of the car from the dirty air that's coming off the rotating tire. So that was the purpose basically of that function right there. And I think also a lot of the lift that is coming from the car is because this big gaping hole is here without any of the air exiting to the ports where it's meant to exit. So a lot of the high pressure is kind of building up underneath the hood, and it's kind of drifting, dragging the car upward, I guess. So usually and hopefully when I get to make the fence, that will kind of redirect all of the air that is coming in here towards these fence to go out of the hood in different sections. Usually the downforce will increase again and things of that nature. Thanks for watching. Please leave a like or subscribe to this YouTube channel if you're interested in more content like this, and also from the Bizzarini project. Please hit us with the like or comment also to what you would want to see in the future from this YouTube channel. I'm Veldboom from SVA Design. Thanks for watching, and I'm out.